Random forests are a type of machine learning algorithm that combines the predictions of multiple decision trees to produce a final prediction. They are popular because they are accurate, robust to overfitting, and relatively easy to train and tune. Random forests can be used for a wide variety of tasks, including classification, regression, and anomaly detection. Hey everyone, and welcome to Learn to Profit. Today, we're going to talk about random forest machine learning algorithms. Random forests are one of the most popular and powerful machine learning algorithms in use today. They can be used for both classification and regression tasks, and they are often used to achieve state-of-the-art results. What is a random forest? A random forest is an ensemble learning algorithm. This means that it combines the predictions of multiple individual learners to produce a final prediction. In the case of random forests, the individual learners are decision trees. How do random forests work? Random forests work by constructing a large number of decision trees, each of which is trained on a different subset of the data and using a different subset of features. The predictions of these individual trees are then combined to produce a final prediction. Why are random forests so popular? Random forests are popular for a number of reasons. First, they are very accurate. Second, they are robust to overfitting. Third, they are relatively easy to train and tune. Handling overfitting. Overfitting is a common challenge in machine learning. It occurs when a model learns the training data too well and is unable to generalize to new data. This can lead to poor performance on test and production data. There are a number of techniques that can be used to identify and mitigate overfitting in random forests. Using a validation set. A validation set is a holdout set of data that is not used to train the model, but instead to evaluate its performance on unseen data. If the model performs poorly on the validation set, this is a sign that it is overfitting the training data. Using regularization. Regularization techniques add a penalty to the model for complexity. This can help to prevent the model from overfitting the training data. Common regularization techniques for random forests include L1 and L2 regularization. Using bagging. Bagging is an ensemble learning technique that works by training multiple models on different subsets of the data and then averaging their predictions. This can help to improve the model's generalization ability and reduce overfitting. Using random forests. Random forests are already an ensemble learning technique, so they are naturally less prone to overfitting than other machine learning algorithms. However, it is still important to use other techniques, such as regularization and validation sets, to further mitigate overfitting. Here are some additional tips for handling overfitting in random forests. Use a large training set. The more data you have to train your model on, the less likely it is to overfit. Use the right number of trees. If you use too many trees, your model will be more likely to overfit the training data. If you use too few trees, your model may not be able to learn the training data well enough. You can use a validation set to find the optimal number of trees for your model. Use the right hyperparameters. Random forests have a number of hyperparameters that can be tuned to improve their performance. Some of these hyperparameters, such as the minimum number of samples required at a split, can help to reduce overfitting. Random forests versus other algorithms. Random forests are a powerful machine learning algorithm, but they are not the only option available. Other popular machine learning algorithms include decision trees and gradient boosting. Decision trees are simple machine learning algorithms that can be used for both classification and regression tasks. Decision trees work by building a tree-like structure that represents the relationship between the features and the target variable. The tree is then used to make predictions on new data. Gradient boosting is an ensemble learning algorithm that combines the predictions of multiple weak learners to produce a final prediction. Gradient boosting is often used for classification and regression tasks. but it can also be used for other tasks, such as anomaly detection. Here is a comparison of random forests, decision trees, and gradient boosting. Random forests accurate, can be computationally expensive to train, robust to overfitting, can be difficult to interpret. Decision trees simple to understand, can overfit the training data, fast to train, can be sensitive to noise in the data. Gradient boosting accurate, can be computationally expensive to train, can be difficult to interpret, can overfit the training data. Which algorithm to choose depends on the specific problem that you are trying to solve and your requirements. For example, if you need a model that is accurate and robust to overfitting, then random forests are a good choice. If you need a model that is simple to understand and fast to train, then decision trees may be a better choice. If you need a model that is highly accurate and can be used for a variety of tasks, then gradient boosting may be the best choice. Here are some general guidelines for choosing between random forests, decision trees, and gradient boosting. Choose random forests if you need a model that is accurate and robust to overfitting. You have a lot of data to train your model on. Choose decision trees if you need a model that is simple to understand and fast to train. You have a small amount of data to train your model on. Choose gradient boosting if you need a model that is highly accurate and can be used for a variety of tasks. You have a lot of data to train your model on. Applications of random forests. Classification. Random forests can be used to classify data into different categories, such as whether or not an email is spam or whether or not a customer is likely to churn. Regression. Random forests can be used to predict continuous values, such as the price of a house or the number of clicks an ad will receive. Anomaly detection. Random forests can be used to detect anomalies in data, such as fraudulent transactions or network intrusions. Some common mistakes to avoid when using random forests. Not using a validation set. A validation set is a holdout set of data that is not used to train the model, but instead to evaluate its performance on unseen data. If you don't use a validation set, you won't be able to tell if your model is overfitting the training data. Not using regularization. Regularization techniques add a penalty to the model for complexity. This can help to prevent the model from overfitting the training data. Common regularization techniques for random forests include L1 and L2 regularization. Using too many trees. If you use too many trees, your model will be more likely to overfit the training data. You can use a validation set to find the optimal number of trees for your model. Not using the right hyperparameters. Random forests have a number of hyperparameters that can be tuned to improve their performance. Some of these hyperparameters, such as the minimum number of samples required at a split, can help to reduce overfitting. Not using feature engineering. Feature engineering is the process of transforming the features in your data in a way that makes it easier for the model to learn. Feature engineering can be a complex process, but it is often essential for achieving good performance with random forests. Not interpreting the results. It is important to interpret the results of your random forest model to understand how it works and what it is predicting. This can help you to identify potential problems with the model and to make better use of the predictions. In addition to these common mistakes, there are a number of other things that you should keep in mind when using random forests. For example, it is important to choose the right features to train your model on and to make sure that the data is clean and well labeled. And that concludes our journey into the world of random forests. If you found this video valuable, please give it a like, and remember to subscribe to learn to profit for more deep dives into the topics that matter. Whether you're just starting your machine learning journey or aiming to become a pro, we're here to help. Thanks for watching, and we'll see you in the next video.